Now we come to lyophilic and lyophobic colloids.
Okay.
Now, what does lyophilic means? Phil means to love. Okay. So
Okay.
lyophilic means liquid loving.
Okay.
Okay. So they are liquid loving colloids. What does that mean? That if I mix the two components of the colloid,
That is dispersed phase and the medium.
yeah, they will easily form a colloidal solution. They are
Okay.
very stable, right? So I'll give you an example. Like dispersion of starch or protein gum in water are examples of lyophilic colloids.
Okay.
Right? They, as I told you, they have strong affinity for each other. The two phases have a strong affinity for each other.
They both are loving each other.
Yeah, exactly. Affinity means attraction, right?
Okay.
So yeah, and because they are so stable, they can be obtained directly by mixing the dispersed phase and the dispersion medium, right?
Yes.
And they are reversible in nature. If you separate the two phases, they can easily be mixed together and they
the
can
colloid
form a
will be
colloid.
obtained.
Exactly. So they are stable, and since they are stable, coagulation or settling is difficult,
Okay.
right? Coagulation is settling of the dispersed phase,
Okay.
okay, which is difficult. Now, at the opposite end of the spectrum, we have lyophobic colloids. Now, phobia means
Fear.
right? So, lyophobic means liquid hating.
Okay.
Okay, yeah. So examples are dispersion of gold, silver, AgCl, or FeOH thrice and sulfur in water.
Okay.
So there is little or no attraction between the two phases. So therefore they cannot be obtained by direct mixing. There are special methods by which these colloids are formed.
And they can easily be coagulated.
They can easily be coagulated because of low stability, and they are irreversible. Like once the colloid is formed and the phases are separated, it cannot be formed again on its own.
By physical methods.
By physical methods,
Okay.
right? We need to employ very specific techniques for to obtain them.
Okay.
Right. Now, there was another classification based on the type of dispersed phase, right? Which was multimolecular colloids and macromolecular colloids and associated colloids.
Exactly.
Right, so we'll come to multimolecular colloids first. They are smaller molecules, the diameter is less than 1 nanometer,
Okay.
and they aggregate to form colloids. They are
Okay.
held by van der Waals forces. They are lyophobic in character. Examples are gold solution. Several atoms of gold together form multimolecular colloids,
Okay.
and or sulfur solution, for example.
Okay. So
So yeah, these are the properties which have to be remembered because they are factual information.
okay. So they aggregate to form particles in the range of colloidal solution.
Right. Now we come to macromolecular colloids.
Okay.
They are large molecules or polymers which act as colloids mostly because of the size of their particles.
So
right?
size is large.
Size is large. It's between suspension and true solutions.
Okay.
Right? And they can be lyophilic or lyophobic. The examples are starch and cellulose in the category of naturally occurring, and for synthetic macromolecular colloids we have nylon and polythene.
Okay.
Next we come to associated colloids, also called micelles. Now what happens is there are some substances which at low concentration will behave like normal strong electrolytes, but
Okay.
if the concentration exceeds a certain value, then they start showing colloidal behavior.
Okay, that's interesting.
So yeah, that is very interesting. So these, and they have a very important application also. We'll see what that is.
Okay.
So yeah, these are molecules smaller than in colloidal state. So they aggregate in concentration, and I'll give an example. Soaps and detergents form micelles.
Okay.
So micelle formation is very important in the action of soaps and detergents as well. Right? So, but it is important to remember that the formation of micelles takes place only above a particular temperature called the Kraft temperature,
Okay.
and above a certain concentration called critical micelle concentration CMC, which is approximately generally around 10 raised to the power minus 3 mole per liter.
Okay.
Now we'll come to a very important part of this chapter.
That is mechanism of the formation of micelle.
Right, the mechanism of micelle formation. Now soap, if you see, it's a sodium or potassium salt of a higher fatty acid.
Okay.
So we can generally represent it in the form of RCOO minus Na plus. Right? I'll give you an example like sodium stearate.
Okay.
Right? It is C17H32
And COO.
COO minus Na plus. Right? So it's a salt. Now what happens is when it is dissolved in water, then RCOO minus ions and Na plus ions are formed. It dissociates.
Exactly.
Okay. Now, as we can see in this figure, the organic part, the hydrocarbon part, this is called the hydrophobic tail.
Because it repels water.
It repels water because it is non-polar.
Okay.
Okay. In most of the cases, we see that polar compounds are hydrophilic and non-polar compounds are hydrophobic.
Okay.
So if you see COO minus Na plus part, it has charges, right? It is
Yes.
polar. So it is the hydrophilic part, water loving part.
Okay.
So it's called the
Water loving head.
water loving head. Exactly. Now we see how micelle formation takes place in water. So when soaps or detergents are dissolved in water,
Okay.
then because the polar part is hydrophilic, then this kind of formation is observed. Okay, the
So
molecules
they form a spherical
aggregate.
structure.
Exactly, they aggregate to form a spherical structure
Okay.
in which the hydrophilic end, the hydrophilic end COO minus,
Okay.
points away from the center, and the hydrophobic part, they come together and they point towards the center. Why is this so? Because these are all hydrophobic, so they are trying to move away from water.
And the structure is surrounded by water molecules.
Yeah, exactly, these structures are surrounded by water molecules. That is why.
Okay.
Right, now what happens is, now how do soaps and detergents function? This is how they function. They form micelles, and then what happens is the grease or the dirt particle, they are mostly non-polar organic
Okay.
compounds in nature.
So they are trapped inside.
So they are trapped inside this micelle.
Okay.
And when you rinse the clothes with water, then this structure itself gets moved away.
Wash away with the water.
It gets washed away with water. Exactly. But then we need to remember one very important point, that this formation takes place only above a critical concentration called CMC, critical micelle concentration.
And above a particular temperature, that is known as Kraft
Temperature.
Okay.
Now we come to coagulation and protection of colloids.
Okay.
What is coagulation? The process of settling of colloids is called coagulation or precipitation of the soil.
Okay.
So basically, the lyophobic soils, they are stable because of the charges present on them. So if I somehow remove the charges, they will come together,
And
form
they'll accumulate.
aggregates, right? And when they form aggregates, they will get heavier, and under
They'll
the
settle
force
down.
of gravity, they will settle down.
Okay.
Okay. So sometimes this is required. Sometimes you want to avoid coagulation. Sometimes
Okay.
it's desirable also. So there are various methods of coagulation, and which can be employed for precipitation or coagulation. So the methods like addition of electrolytes. So if electrolytes are added, then what happens is colloidal particles get precipitated. Why does that happen? They interact with the ions,
Okay.
and we make sure that if the ions carry opposite charge
Okay.
than that present in the colloids, then
The charge will neutralize.
exactly
Okay.
neutralization will take place, and therefore they
And
will
if
lose the
they-
charges. The
okay.
charges will decrease, and again
Finally, they
coagulation
will precipitate.
occur. Exactly. The second is electrophoresis. So if I keep two oppositely charged electrodes,
Okay.
then the colloidal particles move towards
Opposite
the
ends?
oppositely charged. Yeah, exactly, and they get discharged and precipitate.
Okay.
Right. Similarly, there are methods like boiling, persistent dialysis, and mixing of two oppositely charged salts. So basically, the aim is to reduce the charge,
Okay.
because charge is the reason of the stability.
Okay.
Fine. Now we come to a very important rule called Hardy-Schluss rule.
Okay.
It says that the greater the valency of the flocculating ion added, the greater is its power to cause precipitation.
And can you explain what's flocculating ion?
Yeah. So flocculating agent is the substance that I am adding for the precipitation to take place, the electrolyte that I am adding.
Okay.
तो जितनी ज़्यादा उसकी वेलेंसी होगी, उतना ज़्यादा उसकी टेंडेंसी होगी प्रेसिपिटेशन कॉज करने की.
बिल्कुल ठीक.
Right. This is extremely important.
For example, Mg2 plus can precipitate more easily than Na plus.
Exactly, right. So, yeah, this rule is extremely important. Okay, yeah, we'll scroll down.
Okay.
Right. This is extremely important. And questions can be asked based on this actually.
And questions have been asked.
Have been asked previously, right.
Okay.
Now we come to another important concept called flocculation value or coagulating value.
Okay.
Right. The minimum concentration of an electrolyte in millimoles per liter
Okay.
required to cause precipitation of a sol in 2 hours is called coagulating value or
Okay.
तो अगर मेरे पास एक colloid है
अच्छा.
तो the minimum concentration of electrolyte जो मैं उसमें डालूं and the concentration should be in millimoles per liter
Okay.
so that the precipitation happens in 2 hours.
Okay.
That value is called flocculation value. So basically all this is done to standardize things, because if I know the flocculating value of say 5
Okay.
flocculating agents, I can compare them. I can say yes, this
Okay.
let's say Al plus 3 is a better coagulating agent than Ba plus 2.
Yes.
So I know this because these values have been obtained by experiments. Right.
Okay.
So now protection. Now as I said, sometimes coagulation is desirable, sometimes it's not. So when you want your colloid to protect your colloid from coagulation, then there are different methods that can be used. Now lyophilic salts are more stable than lyophobic salts. This
Exactly.
is important, right? And when a lyophilic salt is added to a lyophobic salt, the lyophilic particles form a layer around the lyophobic particles and they
Okay.
protect them from the electrolytes.
Okay, that's interesting.
Yeah, that is very interesting. And since the electrolyte cannot now act on the salt
Okay.
now, no coagulation will take place.
Okay.
Yeah.
So lyophilic salts are
Are added.
protecting lyophobic salts.
Exactly. Let's start with gold number.
Okay.
Gold number is again an important concept.
Yes.
It's basically, we should remember the terminologies, right? So it is defined. We can be asked to find the gold number of a given solution directly. So if you don't know what gold number is, you won't be able to solve the problem at all.
Okay.
So these definitions must be remembered, right? So it is defined as the minimum amount of lyophilic colloid in milligrams which prevents the flocculation of 10 ml gold salt
Okay.
by the addition of 1 ml of 10% NaCl solution. Simple,
Yes.
right? So it is the minimum amount of lyophilic colloid milligrams जो हम ऐड करेंगे in 10 ml of a gold salt by the addition of 1 ml of 10% NaCl solution. Now it is used to measure the protective power of a flocculating agent.
Okay.
So smaller the gold number, greater the protective power.
Okay.
Okay.
Now I get it.
Yeah. Now we come to the third important topic to be discussed in this chapter, emulsions. Right?
Okay.
Yeah. Sorry, this should be emulsions. Yeah. So they are liquid colloidal systems. We discussed that colloidal systems can be of 9 types, right?
Okay.
One of them is liquid. So why are we discussing emulsions separately? Because they are important.
Okay.
They are industrially very important. We'll see how. So if a mixture of 2 immiscible or partially miscible liquids is shaken together, a coarse dispersion of one liquid in the other is obtained, which is called emulsion.
Okay.
Right? Now emulsions can be of 2 types, oil in water or water in oil. Oil in water is when oil is the disperse phase and water is the dispersion medium.
Okay.
So examples of this type of emulsion are milk and vanishing cream.
Okay.
Right? So yeah.
So in milk and vanishing cream, water is the dispersion medium.
Yeah. And the second is water dispersed in oil, WO type.
Okay.
So oil acts as a dispersion medium and water is the disperse phase, and examples are butter and cream.
Okay.
Yeah. Emulsions of oil in water are unstable. For stabilizing an emulsion, a third component called an emulsifying agent is used.
Okay.
Right? So the emulsifying agent forms an interfacial film between suspended particles and the medium.
Okay.
Right? So the principle, like for example, emulsifying agents like proteins, gums, natural and synthetic soaps are there for oil and water emulsions, and for water and oil emulsions, heavy metal salts or fatty acids, long chain alcohols, lamp black, etc. they are emulsifying agents.
Okay.
The droplets in emulsions are often negatively charged and can be precipitated by electrolytes. So with this we come to the end of the theory for the chapter surface chemistry.
So let's start with the questions.
Right.
Okay, let's start with this question. In this question we are given that the coagulation of 100 centimeter cube of gold solution is completely prevented by addition of 0.25 grams of starch to it before adding 10 ml of 10% NaCl solution. So we have to find the gold number of starch.
Right. So let's discuss the definition of gold number first. We saw earlier that gold number is the weight in mg of electrolyte or flocculating agent that must be added to 10 ml of gold sol
Okay.
before adding 1 ml of 10% NaCl to prevent the coagulation of the colloid.
Okay.
Okay, so let's see what has been given to us in the question. In the question, we have 100 ml of gold sol.
Yes.
Okay, while in the standard definition we do talk about 10 ml.
Yes.
So let's see how we go about it. And we know that we are adding 10 ml of 10% NaCl. So this is pretty straightforward, because I know that if I'm adding 10 ml of 10% NaCl to 100 ml of gold sol, then I'll add 1 ml to 10 ml.
Yes.
Right? By simple unitary calculations.
Because the ratio is the same.
Ratio is the same, right. Now I need to find out the weight of the flocculating agent for 10 ml of gold sol.
Yes.
Right. So in 100 ml of gold sol, I am adding 0.25 grams of
Starch.
Right. So in 10 ml of gold sol, I will be adding
0.025 grams
0.025 grams.
of starch.
Right. But I need to, right.
Okay.
0.025 grams of starch will be added.
Yes.
But the standard definition of gold number says I need to find the weight in milligrams. So the weight in milligrams will be 0.025 into 1000, which is
25
So the gold number of starch is 25.
milligram. Okay. Okay, so let's try this question in which we are given that for coagulation of 100 ml of AS2S3 salt, 5 ml of 1 molar NaCl is required. You have to find the flocculating value of NaCl.
Right. So what is flocculation value? Flocculation value is the amount of electrolyte in millimoles.
Okay.
That I will add to 1 liter of colloidal solution to complete its coagulation.
Okay.
Right. So in the question, see, I know what does 1 molar NaCl mean. That I have 1 mole in 1 liter solution.
Exactly.
Right. So that also means I have 1 millimole in 1 ml solution.
Exactly. Yes.
Yeah, right. So in 5 ml solution, in the question I have been given 5 ml of NaCl solution, number of millimoles
Will be 5.
will be 5. 5 millimoles of NaCl are present.
Okay.
Right. Now, volume of solution containing the NaCl solution is 100 ml.
Yes.
Right. While in the standard definition I have 1 liters, which is 1000 ml. So in 100 ml I have 5 millimoles. So in 1000 ml I will have
50 millimoles.
50 millimoles. Right.
Yes.
So it is 50 millimoles per liter is the concentration of NaCl which must be required to coagulate 100 ml of AS2S3 solution. So what is the flocculating value? 50.
Okay.
50 millimoles per liter. Now these units are very important, because if you take out the flocculating value in, let's say, millimoles per or moles per liter, then that won't give you the correct value of the flocculating agent, like
Okay.
flocculating value. So units are important.
Okay. So by this we end this question.